Hello learners, welcome back to Designing AI-driven personalized and adaptive learning environments. I'm Aditya Rajmane and we are going to look at unit number 4.6, which is a demo of Dynamic Bayesian network. Let's dive a little bit deep into Bayesian network tracing and how we can actually compute the dynamic Bayesian network with the learning towards the end and the mastery. So here we are going to look at the Markov assumption. We're going to look at the probability of state state t plus 1 over state t, and finally we're going to compute the mastery. So let's get started. We want to update a node called concept to indicate whether the students have learned a skill or not. The node is based on students' response to a question. It is a Boolean value of 0 or 1. 1 is correct, 0 is an incorrect value. You can find a lot more about Bayesian knowledge tracing in these two research papers which are given below. For today's example, we are going to look at these 4 different probabilities. First one is PL0, which is the initial knowledge. Second one is PT, which is the acquisition. What does acquisition mean? That the transition, that it is the probability a rule will make from transitioning from unlearned to the learned state following an opportunity to apply rule. We're going to look at the guess probability, which is a student will guess correctly if a rule is in an unlearned state, and slip probability, that the student will slip or make a mistake if the rule is in the learned state. This is a little bit more interesting, and I'm going to give certain numbers to it at first so that we can solve a numerical based on PL0, PT, PG and PS. So let's see if we can give some numbers. So my first number that I'm going to give for PL0 is 0.3, PT I'm going to give as 0.15, P guess I'm going to give it as 0.2, and then slip probability I'm going to give it as 0.1. This is really interesting. Student will guess correctly if a rule, if the rule is in the unlearned state. That means we are assuming that the student is in an unlearned state. The student is guessing the answer. Over here, similarly, slip is the opposite, where student will make a mistake and they know the answer. If a rule is in a learned state, student knows the answer, but yet they made a mistake. That is my slip probability. These numbers are to be assigned by the developer, and we're going to see how these different numbers differ and change the learning trajectory of a particular student. Here is the numbers that I have written. Okay, so let's see, based on these different numbers, what's going to happen if a student answers correctly. So we have an observation, which I'm going to name it as R. So I'm going to see of probability of learner when R is 1, that means the observation, the response that I've put in is correct. So it says it is P of learning times P of not slip. So this can be written as 1 minus probability of slip plus 1 minus P of learning, 1 minus P of learning, I'll write it again properly, 1 minus P of learning times P of guess. Now we are going to substitute these values in from the previous one. So our initial knowledge was 0.3, 1 minus 0.1 plus 1 minus 0.3 times 0.2, which is going to give us an answer of about 0.41. So what does this essentially tells us? This essentially tells us that 41% is the chance of students answering correctly if they have answered in this particular situation. Why is this important? This chance correctly is important for the next step. So this is the formula for updating the learner state. We're going to look at it in much more detail. This is not the final formula for skill mastery. This is the formula for updating the learner state. If you observe this formula very closely, when you answer correctly, over here is the last thing that we computed, which was chance. So let's write this. So P of learner updating, hence t plus 1 of r equal to 1, which was the observation, is what? P of learner at r equal to 1 over L times P of L. So I am substituting this and this easily. Now let's take a moment and pause to understand why I have done this. Over P of r equal to 1. The reason being, what exactly is a slip? We have looked at what is slip. It is the probability of student that they are making a mistake if the rule is in the learn state. That means they have answered it incorrectly and they are in the learn state. Hence, we can easily assume that they are in a learn state and they have answered it correctly is the opposite of probability of slip. Hence, the two can be interchanged. So I can write it 1 minus probability of slip upon P of r. So some formulas about Bayesian network tracing will have either 1 minus P of S, or they might have P of observation equal to 1 over L. So don't get confused if those two formulas are interchanged. Okay. So let's substitute the 1 minus 0.1 times 0.3, and we have got 0.41 from the previous answer, so it goes to about 0.6585. So that's my probability of learning. Now finally we've got how I have to update this particular thing. I need to update the probability of learning for the next state using the probability of learning into the probability of transition. So this is my probability of transition, which I'm going to use now. So let's see how I can use that. So probability of learning in the next state is probability of learning in the next state which we have observed. In our case, our observation is r equal to 1, which we have just computed, plus 1 minus probability of same thing, plus 1, r equal to 1, times probability of transition. I'm going to put in the probability of learned value from here, which is 0.6585 plus 1 minus 0.6585 times probability of transition, which is 0.15, which comes out to around 0.7097, which we can assume is 0.71. What is happening over here? This number is really important. What was my initial learning probability? It was 0.3, and now it has jumped to 0.71 in the next state. Why? Because I answered correctly. This is what Bayesian knowledge tracing is. I have an initial probability, I answer something correctly, and my probability jumps up. And these three are there as guardrails for help me intelligently assign these probability values. What happens if the response is incorrect? So let's see if the response is incorrect, how I can compute it. So this is the formula. The denominator over here is something that we're going to solve before. So if the response is incorrect, it's P of L0 times probability of slip. So you have slipped, your response is incorrect, but I'm going to give you all some leeway because you might know the answer, plus 1 minus probability of learning times you have not guessed, probability of not guess. So not guess I can write as 1 minus probability of guess. So let's substitute these things inside the formula. So this is 0.3 times 0.1 plus 0.7 times 0.8, which gives us the value of about 0.59. Okay, so I've got the denominator now, 0.59. Okay, now let us substitute these two values in. P of L0 times probability of slip. In this case it is 0.1 and 0.3, which gives us the answer of about 0.0508. So now we have got the answer. Let's see what is the transition. Over here, since the answer was correct, my transition went from 0.3 to 0.71. Now let's compute. If my answer is wrong, what is my learning probability for the next one? So if my answer is wrong, my learning probability for the next one, here my P of LT plus 1 observed is R equal to 0, which we computed, plus 1 minus same thing P of LT plus 1, where rewrite it, P of R equal to 0 times probability of transition, which is going to give me a value of 0.0508 plus 1 minus 0.0508 times transition probability is 15%, 0.1932. This is interesting. So you only have 19.32% chance of getting the next question correctly. So next time your initial learning mastery score is going to be 0.1932. So if you get an answer correct, it goes to 0.71. If you get the answer wrong, it goes to 0.1932. Answer wrong. Okay, now but you might say, this is good. What is dynamic in this nature? A dynamic thing in this nature is going to be, you're plugging these values again and again into the initial knowledge and you're getting the next answer. And to demonstrate that, Center for Educational Technology at IIT Bombay has created a small HTML based application. So I'm going to quickly show you all the application. So this is the Bayesian knowledge tracing demo. So over here we have the initial probability, guess, slip and learning. I'm going to keep the values same so that you all can understand how this computes. So earlier my initial knowledge was 0.3, my guess probability was 0.2, my slip was 0.1 and my learning was 0.15. Okay, so I'm going to click on correct. I'm going to click on reset. So now when I click on reset, it sets my initial value correctly to 0.3 and it now gives me this graph. So I'm going to first say I'm answering it correctly. What does it do? My posterior is 0.659. We computed, I think similarly, our posterior 0.6585, that's what we computed. And then it says 0.71 as the next skill. So it goes to 0.71, 0.710. Let's reset it and see what happens if we do it wrong. If we do it wrong, posterior 0.051 and 0.193, which we've computed, if we get it wrong, way of learning. Let's do it a little bit more times. So based on this, I'm gonna answer the next question correctly. Oh, it shoots up directly to 0.59. I'm gonna answer the next question correctly, next question correctly, next question correctly. See where my mastery is going. My mastery now is 1. That is 100%. I'm going to go next person wrong a little bit. My mastery is still going 0.952. The reason being, I'm marking it wrong, yet my guess percentage is very small. If I increase my guess percentage, guess probability and marking it wrong, see how fast it goes down. If I reduce it less, see how slow it goes down. This is really important for you all to understand how your learner works and what is guess probability and slip probability. Now I'm answering things correctly. See how fast it goes up. The reason being, I'm saying the probability of a person's slipping is just 0.1. If I move it quite a lot, let me answer a few wrong questions. Okay, if I move it a little bit more and I start answering it correctly, it shoots up really fast because what it is saying is, oh, this person knows what the answer is, they're just slipping. If I do it less, it will be a little bit more conservative. I feel like this interactive tool hence gives a really good idea of how these different probabilities work, the guess probability and the slip probability. Here you all can also see the transition that we have had into different probabilities from initial to the next transition of the probability. And here's a tiny readme about this model. What is BKT, how it is computed. And here is also a reference to the from where this model has come from. So that's all, folks, about how BKT is computed, how dynamic Bayesian network is computed. I hope you all use it or use something very similar into creating your adaptive tutors in future. Thank you so much.